So that was my spring break. What's up, everybody? Hope you guys are doing well. Hope you guys had a great spring break and ready to get back to some math. We're excited, right? Right? So a few quick announcements. Geometry, you guys have your test this Thursday at 10 a.m. Second group will be going at noon. If you guys need help, tomorrow is our review day. No video lecture tomorrow. All you're going to be doing is emailing me for questions if you have them. If you need video, chat, video, Google Hangouts, whatever, help, let me know and we'll schedule a time. But tomorrow is review only. So make sure you get in contact with me if you need help for the test on Thursday. You guys can use one side of a 3x5 index card. I'll trust that you do that. Algebra 2, you guys have a quiz this Thursday. First group going at 10 a.m., second group going at noon, just like before. Tomorrow's video lecture, make sure that you guys actually attempt the worksheet before watching it, because the video lecture is just going to go over the worksheet. It's just going to show how to do all the problems. So try and do the worksheet before watching the video. Lastly, make sure you guys check your email because I'm sending out a new policy on late submissions for tests and quizzes. So all the details are in the email, but make sure you look at that. I'm glad we're back. Hope you guys had a restful spring break. Looks like we'll be doing the online format a little bit longer. So make sure you guys stay positive, make sure you guys stay focused, and yeah, enjoy the lecture. See ya. Alright, so today we're looking at section 4-3b, which is evaluating, solving, and graphing our logarithms. So let's do a quick review of what we talked about with converting from exponential to logarithmic form last week, or I guess the week before. But let's say that we have something that is in exponential form. I want to convert to logarithmic form. So all I'm going to do here to convert to log form, I'm going to say log. Remember, I need a base. I need the actual number I'm taking a logarithm of. And remember, a log equals the exponent. So that's the three parts I need. The base goes down to the basement. A logarithm equals the exponent. There's my exponent. And I fill in the leftover. So that's how I convert from exponential form to logarithmic form. Let me write this clearly. So log base 2 of 64 equals the exponent, which is x. Now to convert from logarithmic form to exponential form, this is where I recycle. So recycle and get 3 raised to the power of x equals 81. So today what we're looking at is how to actually evaluate these logarithms. For example, what does x have to be? What does x have to be here to solve this logarithm? Now here's a few special properties you should know before we get into it. So if we look at our logarithmic form, and let's say that I have something where the base and the actual number I'm taking the log of are the same. So an example would be something like this. Log base 10 of 10. Well, no matter what, that's always going to equal 1. Because when you recycle this, you get b raised to the power of 1 equals b. And so you're always going to have that equaling 1. And we'll come across this later on. And sometimes I say it's double b if you see those the base and the actual number you're taking the log of if they're the same. Now the other one is the logarithm of 1. Let's say we're taking the logarithm of a number and that number is 1. Well, that's always going to equal 0 because when you recycle, you get b raised to the power of 0 equals 1. Well, any number raised to the power of 0 is always going to equal 1. So if you ever see this number as a 1, your answer is always going to be 0. Now last one is the common logarithm. A common logarithm is where we don't write the base. So for example, this right here. So I could write it like log of 5. Notice that I don't have the base there. Well, if you don't actually write the base, it's assumed that the base is 10. It's assumed to be 10. So if you see something like this where you don't actually see a base, it's going to be 10. We're always going to assume it's 10. So if you want to write a logarithm like that, there's a imaginary 10 there, but you don't have to write it if it is a 10. If it's a different number, make sure you do write it. So this is just a few special properties and then the common logarithm you need to know. But let's go into actually evaluating our logarithms. Now the difference between evaluating and solving is that when we evaluate, notice that there's no x here. When I actually solve for x, notice that I have an x. Notice I have an x here. So when we say solve, you're actually going to solve for x. When I say evaluate, there's no x, but basically what we're going to do is we're going to add an x to solve for this. But that's the difference there. So let's say that I want to evaluate this logarithm in a. Well, what does this log equal? The log equals the exponent, so all I'm going to do is just add equals x. That's step one. Then, so now it's kind of a solving problem because I have an x in there. Now I'm going to recycle, and that will give me, after I recycle, I get 4 raised to the power of x equals 1/4. Well, what does x have to be to make 4 equal 1/4? Well, hopefully you guys remember I need to bump the 4 down to the bottom, which means x has to equal -1. So this logarithm, so I'd be okay if you stop there, but you could write it like this: log base 4 of 1/4 equals -1. Remember, a negative exponent flips it. Top goes to bottom, bottom goes to top. What about example B? Log of 1,000. Now notice I don't have a base there, so this is the common logarithm. Since I did not write a base, it's an assumed 10. So I have an assumed 10 right there, which I don't actually need to write. But let's go and add equals x. I'm going to recycle, so I'm just going to add this 10 just so you guys can see. After recycle, we get 10 raised to the power of x equals 1,000. Now what does x have to be to make 10 equal 1,000? So 10 to what power equals 1,000? Well, if x is equal to 3, that will give me 10 cubed, which equals 1,000. So the log of 1,000 equals 3. So I'll accept either of these as solutions. Example C, log, let me add this divider here, log base 2 of 1/16. What does that evaluate that? What does it equal? I'm going to put equals x. I'm going to recycle. 2 to the x equals 1/16. Well, 2 raised to what power equals 1/16? Now, the trick here is if I can somehow get the x to a power equals x to another, let's say, z. Well, if these two numbers here, if I can get these two numbers to be the same, well, that means my exponents also have to be equal. If they're equal, I can set them equal and solve for the unknown. So this might be kind of confusing, but let's look at the example and hopefully that'll make more sense. So what we're going to do, I have 2 raised to the power of x. I'm going to try and somehow write the 1/16 as 2 raised to some power. That's what I want. I'm going to go from 1/16 to 2 raised to some power. So what I'm going to do, well, 2 raised to the power of 4 equals 16, but I need to bring it to the top, so I have to have -4 here. So 2 to the -4 is actually 1/16. Well, since these two numbers are the same, that means my exponents also have to be equal. So basically I'm going to take my exponents and write another equation of x just equals 4, and that is my answer. And if I needed to solve, I could, but since I have x equals -4, I can stop there, and that's my solution. So that's what I was meaning when I said try and get these numbers the same, Because if you get those bases the same, then the exponents also have to be equal. So that's the trick here. Now example D, this one actually is our double base. This is this one right here. Now, the trick with this one is that since I have a 10 here and a 10 here, this will equal, you could put it equal to x, but if I didn't have this power here, well, that would just, I'll do it really quick. I'll show you what I mean. Say I didn't have that. Well, this, I could put x equals x, recycle, 10 to the x equals 10. Well, x would have to be 1. But since I have this negative 4 as the exponent of the 10, well, the trick here is that all you're going to do is just cancel these out. And this will be equal to negative 4. Really what's going on is that you take log base 10 of 10 raised to the negative 4. Set it equal to x. I recycle. When I recycle, I get 10 to the x equals 10 to the negative 4. Again, there's those common bases, which means the exponents have to be equal, so I get x equals negative 4. The trick, though, is that whenever you see, this is going to make your life super easy, whenever you see log base 10 of 10 raised to negative 4, if those two numbers are the same, that's your answer. So for example, you could have log base 2 of 2 raised to the 8th. This would be equal to 8. So if these are the same, the exponent is your answer. So that's how you evaluate. Now let's look at solving. So solving is basically the same thing, but the x is going to be in a different position. Instead of being on this side always, we can switch it up and put the x right here. We put the x right there. That's the same thing as evaluating. We can put the x right there. So we're basically just going to swap where the x is, mix up the x, and then solve for it. But the x is already in the equation. So same thing, I'm still going to recycle. So I get x raised to the 3 over 2 is equal to 27. Now the trick here is that I have x raised to 3 halves. What I want to do, let me erase this really quick. So x to the 3 halves equals 27. I'm actually going to take this side. I want to make it this as x to the power of 1. Well, if I multiply by the reciprocal right here, multiply by 2/3, well, multiplying that will give me 1, but what do I do to one side? I have to do to the other. So these cancel out, and I'm left with x to the power of 1 equals 27 raised to the 2/3. So now, since I have x raised to the power of 1, that's just x. I have x equals this, but let's go and simplify 27 raised to the power of 2/3. So what, so I'll come up here to finish, does 27 to 2/3 power equal? Well, I can put this in radical form. 3 goes there, 27, and I'll square it. Well, the cube root of 27 is 3, so I get 3 squared and get x equals 9. So if I were to take the log base 9 of 27, that will equal 3 halves. Next we have log base 1/2 of 8 equals x. I'm going to recycle. Basically you're always going to recycle to start. So get 1/2 raised to the x equals 8. Well, again, if I can get the same base for both of these, then my exponents have to be equal. That's kind of the difficult thing with evaluating and solving logarithms. There's a lot of different methods to solve. You just have to be creative, and you have to kind of think outside the box and see what's gonna work best for you. So this, I'm going to write this as 2 to a power, and somehow get it equal to 2 raised to another power. So how do I convert this to that, and how do I convert 8 to that? Well, the 8 is easy, because 2 cubed is 8. So 2 cubed is 8, those are equal. Now how do I get these equal? Well, I want to bring the 2 up, so I have to have a negative 1, but I can't forget about the x. The x is still in the power, so I have to keep that x there. So I get 2 to the negative x equals 2 cubed. Now since my bases here are equal, it means my exponents also have to be equal. So to finish, I can basically just cross those out and be left with negative x equals 3. And solving for x, I get x equals negative 3. Now you guys might have been able to see this at the beginning, right here, that fx was equal to negative 3, then it would equal 8. If you can evaluate that mentally, that's totally fine. I'm just trying to give you guys methods to solve for everything. Example C, log base 4 of x equals negative 2. Let's just go ahead and recycle. 4 to the negative 2 equals x. One negative exponent. It means I flip it. So 1 over 4, now it's positive. So 4 squared equals x. And then x is equal to 1 over 16. So that one's pretty easy. This is a good quiz question here. Notice that I have the radical here. So I'm still going to recycle to start. So recycle. Now I'm going to take this radical form, and I'm going to change this to 3 to the 1/2, because remember 1/2 is the same thing as square root. X equals 27 to the negative 1. So I move that up, so I have to have a negative exponent. I convert from this to that. Now, the key here is that I have a 3 here. I want to get the 27 as a 3 as well. If I can get the same bases, then my exponents have to be the same as well. So I have 3 to the 1/2 x equals, well, 3 to what power equals 27? Well, 3 cubed equals 27. So I'm going to write this as 3 cubed, but I also have this negative 1 here. So what I get is 3 to the 1/2 x equals 3 to the negative 3. Now I could have gone from here to here quicker. Could just recognize that 3 to the negative 3, or 3 cubed is 27, then flip it, so add that negative. So there's different methods. You don't have to do exactly like this, but you could, obviously. So since my bases are equal, that means my exponents also have to be equal, which means I can basically cross these out and get 1/2, move the equal sign up. 1/2 x equals negative 3, and now I just solve for x, so I'm going to multiply both sides by 2. What I do to one side, I do to the other. Those 2's cancel out, and get x equals negative 6. And that is my answer. Now this one, I do see a lot of people mess up, but make sure you know how to do this one. Hint, hint, because you will see something like this on the quiz or test, or yeah. Last one for solving. Log base x of 1 over 16 equals 4/3. So again, I recycle. 1 over 16. So that's what I get when I recycle. This is exponential form. So the key here is, notice that on a little trick, when the x is in the exponent, that's when I try and get the same base. Here, the x was in the exponent, I try to get the same base. Notice on this one, the x was not in the exponent, it was the base. So when the x was in the base, I try to get it as x raised to the power of 1. So I multiplied these two together. I got x to the 1. I did it to both sides and then solved for x. So when the x is not in the exponent, like this, when it's actually in the base here, that is when you're actually going to multiply by the reciprocal to both sides, and then that will give me x to the power of 1, because 4 times 3 over 4, 3 times 4 is 1. And I can just simplify, in this case, the right-hand side of the equation. So hopefully that makes sense. If the x is in the base, multiply the reciprocal. When the x is in the base, multiply the reciprocal, and then solve the right-hand side. But how do I solve this? So x is equal to, if I write this as radical, the fourth root of 1 over 16 cubed. I could separate vertically and cube the whole thing. So I get the fourth root of 1 is 1. The fourth root of 16 is 2. So I cube it and get x is equal to 1/8. And that is my answer. This might make a good quiz question too. And that's really the difference. If the x is in the base, multiply the reciprocal. If the x is in the exponent, like this one, get the same base. And then set the exponents equal to each other. Alright, so last topic is graphing. How do I graph how do I graph logarithmic functions? So the key here is that you have to know the inverse. So basically what we're going to be looking at is, if I have an exponential function like this, the inverse is going to be this guy right here. And notice that when I did this, all I did was take y equals. I started here, took y equals. I added a logarithm, and basically took these two numbers and just shifted them down. The 2 becomes the base, and the x goes right there. And that will be how I graph them. And I can work the opposite way as well. So it works both directions. But that's the key. I just take these, add a log, and shift them down. So how does that help us when solving or when graphing a logarithm like example A here? What we're going to do first is graph the exponential function. I'm going to take these two numbers and just shift them up and get this. And that'll be the inverse function. So this is the inverse of this. What do I get when I graph this? I could do this by hand. I could take, I'm going to make an XY table. Start with -2, go up to +2, add, take away numbers as needed. So I could take 3 to the -2, that's going to be 1 over 9. I could take 3 to the -1. Well, that's going to give me 1 over 3. 3 to the 0, that's going to be 1. 3 to the power of 1, that's 3. 3 squared is 9. So those are the xy coordinates for the inverse of this log. If you guys remember from previous lesson, if I take the xy coordinates here and want to take the inverse, all I have to do is swap the x and y coordinates. So I'm literally just going to take these two, all the values, and just flip them. So this here, so this box here, that will be the xy coordinates for my original function. So I get 1 over 9 will correspond to -2. 1/3 will correspond to -1. 1, 0. 3, 1, 9, 2. So a quick review. I'm going to take my original function. I take the inverse of the log, which is this. I find those xy coordinates. Then I swap these xy coordinates or I take the inverse of those xy coordinates to get back to my original function, the log function. And now, here, I have the xy coordinates, which I can then graph. And that would be so here's each of the coordinates xy coordinates that I had originally. Oops, went too far. So these were the ones that I had, and all the other ones are extra ones. And obviously you take those and then plot your function. So all you got to do, you have y equals log base 3 of x. I go from here to the inverse, which is y equals 3 to the x. I get my xy coordinates. Then I go back to the original and find those xy coordinates, and all I got to do for that is swap those and then graph. So for example, I had the 0, 1. Just look at that. So I had 0, 1. So I swap and then graph. And that's it. So if you guys have any questions, email me. You guys will have a lot of questions on the test and quiz, like these, we have to solve and then evaluate, and I have maybe 1 or 2 on the graphing. Now one last thing, and we'll be done, is that for tomorrow, I will give you guys the worksheet and a video lecture. But I want you guys to try the worksheet first and then watch the video lecture, because the worksheet, I'm not going to collect it for a grade, but the worksheet, I'm just going to go over that in the video lecture, just go over every single question and show you guys how to do it. So make sure you do the worksheet, attempt the worksheet before watching the video lecture tomorrow. Alright, see ya.